This is sample test version number 1 for the upcoming test on foiling, factoring, and completing the squares. Let's start with question number 1, where the instructions tell us that we're going to have to multiply the following, and it says 7n plus 2 squared. So we recognize that this looks like 7n plus 2 times 7n plus 2, and what we're going to do is we're going to FOIL. We remember that means first, outer, inner, last, and we're going to simply be multiplying. And we know that 7 times 7n is going to give us 49n squared. 7n times 2 is going to give us positive 14n. Likewise, 2 times 7n is going to give us positive 14n. And then finally, 2 times 2 is going to give us plus 4, positive 4. Next, what we need to do is take a look at this expression to recognize that we can combine like terms. So this is going to be 49n squared plus 28n plus 4. This is our answer. Let's take a look at question number 1b. We're going to rewrite this as 2n minus 7 times 2n minus 7. And again, we're going to FOIL. And this is going to look like 2n times 2n, which is, of course, 4n squared. 2n times negative 7 is going to be negative 14n. Negative 7 times positive 2n, once again, is going to give us negative 14n. And then finally, last, negative 7 times negative 7 is going to give us positive 49. I can see that we can combine like terms. So ultimately, this is going to look like 4n squared minus 28n plus 49. Let's take a look at question 1c. We're going to be multiplying 7n times 7n. That's going to give us 49n squared. 7n times negative 2 is going to give us negative 14n. 2 times 7n is going to give us positive 14n. And then lastly, 2 times negative 2 is going to give us negative 4. And can we combine like terms? We sure can. And I know that negative 14n plus 14n cancels out to 0, right? So we're left with simply 49n squared minus 4. This is our answer. For question 1d, our instructions are to multiply. So we're going to be distributing negative 8a squared, b to the third, into each of these three terms. Let's dive right on in, and we're going to look at negative 8 times negative 3 is going to give us positive 24, right, if we're just looking at the coefficients. And then a squared times simply a is a to the third. B to the third times b is going to be b to the fourth. Why? Well, we remember that when we multiply exponents, we're actually adding them. And what do I know? I know that negative 8 times positive 4 is going to give us negative 32. A squared times a is going to give us a to the third. And then b to the third times b to the second is going to give us b to the fifth. And then lastly, negative 8, a squared, b to the third times negative 1 is going to give us positive 8, a squared, b to the third. And that's our answer. Question number 2 wants us to rewrite by multiplying. So what we're going to do is we're going to multiply 5n into each of these three terms, and then 3 into each of these terms, making sure that we're combining like terms and simplifying. I know that 5n times n squared is going to give us 5n to the third. 5n times negative 2 is going to give us negative 10n squared. And then 5n times 1 is going to give us just 5n. 3 times n squared is going to give us positive 3n squared. 3 times negative 2n is going to give us negative 6n. And then 3 times positive 3 is going to give us positive 3. So now what we're going to do is we're going to take a look at this. Can we combine like terms? I can see that there is only one variable raised to the third term. There's only one 5n squared, 5n cubed. So I'm going to write 5n cubed. What about negative 10n squared and 3n squared? We can combine those like terms, and that's going to give us 7n squared. And then I see that we've got 5n and negative 6n, so that's going to leave us with negative 1n or simply negative n, and 3 is by itself. We can't combine that with anything, so we'll bring it down. And this, ladies and gentlemen, is our answer. Question 3 asks us to solve, and I know that means that we need to get x by itself. And to start, what we're going to have to do is simplify the left side of this equation. And we've got to get 2x plus 3 by itself, because I can see that right now it's squared. So how do we do that? Well, we're going to take the square root of both sides. And if we take the square root of both sides, then we know that the left side simplifies to just 2x plus 3. The square is gone. And it's equal what? It's equal to the square root of 25 is plus or minus 5, because 25 is a perfect square. And what do we need to do now? We're going to do the inverse operation by subtracting 3 from both sides. And so now we've got 2x equals negative 3 plus or minus 5. And what's next? Well, we got to get x by itself. So again, we're going to do the inverse operation. We'll divide both sides by 2. And that's going to leave us with x equals negative 3 plus or minus 5 divided by 2. And these are roots, and what I can tell is that there's going to be 2 answers to this. So I'm going to rewrite this like negative 3 plus 5 divided by 2 equals what? And then I'm also going to write negative 3 minus 5 divided by 2. And so we'll do the left side first. And I can see that negative 3 plus 5 is going to give us what? Positive 2. So 2 over 2 simplifies to 1. Oh, okay, so that's one of the roots. That's 1/2 of the answer. And let's take a look at the other half. Negative 3 minus 5 gives us what? Negative 8 over 2. And negative 8 over 2 simplifies to what? Simply negative 4. Negative 4 is the other half of the answer. That's the other root. This is the answer, ladies and gentlemen. There are 4 parts to question number 4, A, B, C, and D, each requiring us to factor. I've done extensive video tutorials on this, so I'm going to keep this brief, and if you're feeling a little confused, I urge you to check out those other tutorials. And so what we need to do is we need to factor. We need to say to ourselves, what is the greatest common factor with these 3 terms? What is the GCF? And if we just take a look at the coefficients, right, I can see that it's negative 20, 24, and 32. What is the greatest common factor? And I know that it's not 2, even though 2 goes into each of these 3 terms, but instead it's 4. And so I'm going to write 4 what? When we take a look at the variables, I'm going to look at just the a's for a second. And at most, how many a's do each of these 3 terms have in common? This third term right here, right? It doesn't have an exponent, so we can pop a little invisible 1 up there, and I can see that at most they have just 1 a. So I'm going to write 4a, and at most, how many b's does it have? 2, b to the second. Great, and so now what we need to do is we're going to open up this parentheses, and all right, we need to ask ourselves, all right, 4ab squared times what gives us negative 20, a squared, b to the third, and we know that it's going to be negative 5ab, right? Because positive 4 times negative 5 is going to give us negative 20. A times a gives us a squared. B squared times b gives us b to the third. Tremendous. 4 times what gives us 24. I know that 4 times 6 gives us 24. And that's going to look like 6a squared. And then that's it, because I can see that we've already factored out b squared. And this has got b squared, so we're good with 6a squared. Lastly, 4 times what gives us 32? We know that it's going to be positive 8. And then a times what gives us a? Well, it's just the original a, so we're not going to, you have already factored that out. B squared times what gives us b squared? Nothing. So what we can do is simply leave it like this, and we just factored question 4a. Nice. Let's factor question 4b, and I can see that this is a difference of perfect squares. So we're going to set that up with 2 sets of open parentheses, and I know that what times what gives us 25? Well, because this is a perfect square, 5 times 5. Likewise, m to the 4th is a perfect square, so it's going to be 5m squared times 5m squared. And then the second half, I can see that we've got negative 49. So because this is a negative, I recognize that it's going to be plus minus. And then what times what gives us 49? 7. times 7. And then I can see that it's n to the fourth, so I'm going to make this n to the second, n to the second, and we just factor this out. Once again, we need to factor for question 4c, and what I know is that the leading coefficient is 1, right? And even though we don't see it, we can pop in a -1 right there. And why did I do that? I did that because we know that in this scenario, we're going to figure out what two numbers multiply to 9 and add to -6. So again, we're going to set up two open parentheses. What times what gives us a squared? A times a gives us a squared. What two numbers multiply to give us 9? Well, I know that it's going to be 3 and 3. And again, what two numbers multiply to give us positive 9? It's got to be either positive 3, or -3 and -3. And because this is -6, then clearly it's going to be a minus 3 times a minus 3. And we can simplify that further, like a minus 3 squared. And this, my friends, is the answer. Likewise, with the last problem, I can see that the leading coefficient is 1. And so what we can do is we can ask ourselves, all right, what two numbers multiply to 25 and add to positive 10? Like before, I'm going to set up two sets of parentheses. And I know that it's going to be h times h because h times h gives us h squared. And what two numbers multiply to 25? Well, it's going to be 1 and 25 or 5 and 5. And I know that this is a perfect square. And then it could be either -5 times -5 or +5 times +5. And it's definitely going to be +5 times +5. And I know that if we FOIL this, right, if you want to check your work, I can see that, well, actually, this is the answer. Alternatively, we could write it like h plus 5 squared, right? And if we wanted to check our work, I know that h times h is h squared, h times 5 is 5h, 5 times h is 5h, 5 times 5 is 25, and 5h plus 5h gives us 10h. This is the answer. Question number 5 says, solve by factoring. And I know that means that we're going to have to isolate for x. How do we do that if we're factoring? Well, the first thing I recognize is that we're going to have to shift over 36 to the left side. To do that, we're going to subtract 36 from one side and then from the other. And what does that leave us with? That leaves us with x squared minus 9x minus 36, crucially, equals 0, because don't forget, we've got to find the zeros. We've got to find out what the roots are. That's how we're going to be solving this problem. And I can see that the leading coefficient is 1. And so we've got to ask ourselves, what two numbers multiply to -36 and add to -9? So I'm going to do this a little bit methodically. I hope that's okay with you guys. And so what do I know? I know that 1 times 36 is 36. Great. 2 times 18 is 36. Or 36 divided by 2 is 18. 36 divided by 3 is what? It's 12. 36 divided by 4 is 9. And then lastly, 6 times 6 gives us 36. So what do we have here? We've got 1, 2, 3, 4, 5 pairs of numbers, right? And we need to think about, all right, so all of these multiply to give us 36, right? Or in this case, it's going to be -36. What combination, or rather, what pair works together so that when some combination of positive and negative signs give us -9? Well, it can't be 1 and 36, right? Because if it's going to give us either 37 or 35, that's not going to work. Neither is 2 and 8. 6 and 6 is going to give us either 0 or 12. That won't work. You know what? 4 and 9 won't work, but 3 and 12 sure will. Nice. So how do we write that? We're going to set up two sets of parentheses, always equal to 0. And we know x times x is going to give us x squared, right? That's easy. All right, and we also know that it's going to be 3 and 12 because 3 times 12 gives us 36. So I'll write 3 and 12. And now we need to say, all right, this is a negative number, right? -36 is negative, so one's got to be positive, one's got to be negative. Which is which? Well, if this is -9, I know that it's going to be x minus 12 and x plus 3, because when we FOIL this, that's going to give us -9x. We're not done yet, though. We're almost done. We're almost there. But to solve for this, what we're going to need to do is we're going to set each equal to 0, so x plus 3 equals 0. And then we've got x minus 12 equals 0. Then if we subtract 3 from both sides and then add 12 to both sides, that gives us what? X equals negative 3 and x equals positive 12. Don't forget to do that really important step. This is the answer, ladies and gentlemen. Question number 6 asks us to solve for the roots by factoring, and I can see that it's set equal to y. What I'm going to do is I'm going to rewrite this, and I'm going to make it set equal to 0, because again, we're going to be finding the roots. We're going to be solving for these zeros. And how do we approach this? Well, I can see that because this trinomial is written in the format, we could solve it using factoring by grouping. We could use our number sense method. We could even use the quadratic formula. Instead, however, what we're going to do is we're going to ask ourselves, does this trinomial have a GCF? Is there something common? Is there a greatest common factor? And yes, there sure is. What we can do is we can factor out 3 from each of these 3 terms, right? Because 3 goes into 3, obviously, as well as 6 and negative 24. And so when we factor out 3, well, what does that leave us with? X squared plus 2x minus what? 8 equals 0. All right. So now what we need to do, because the leading coefficient is 1, is we're going to say, all right, what 2 numbers multiply to give us negative 8, but add to positive 4? And I know that when we set it up with 2 sets of parentheses always equal to 0, x times x always gives us x squared, right? So that's pretty obvious. What times what gives us 8? Well, I know it's 8 and 1, and I know it's also 2 and 4. And what I'm going to do is I'm going to write 4 and 2. And what about the signs? Well, I can see that this is a positive 2x. So I'm going to make this a positive 4 multiplied by a negative 2. And that looks great so far. We've got to solve for the zeros. So what we're going to do is we're going to extract this set of parentheses and this set. And it's going to look like x plus 4 equals 0 and x minus 2 equals 0. We're going to do a little inverse operation so that x, when we subtract 4 from both sides, x equals negative 4. And then x minus 2 equals 0. We're going to add 2 to both sides. X equals positive 2. That's it. Easy peasy. Question number 7 asks us to solve by factoring. And when we take a look at this trinomial, what I notice is that the leading coefficient is not 1 this time. In fact, it's 6. So we could solve this using either the number sense method or the method by which we factor by grouping. We're going to factor by grouping in this case. And so we're going to multiply 6 times 2, and that gives us 12. So what we're going to need to do is we're going to need to split up 7x by figuring out, all right, what 2 numbers add to 7x and multiply to 12? All right, so I know that when we're figuring out factors for 12 are, it's 1 and 12, it's 2 and 6, it's 3 and 4. Do any combination of those, when added, give us 7? Yeah, it's 3 and 4, right? So I'm going to rewrite this like 6x squared plus 3x plus 4x plus 2. And then this, of course, is equal to 7. We're solving. We've got to figure out what the roots are. So now what do? Well, we split up 7x into 3x plus 4x. And I can see that we've got 4 terms. What we're going to do now is we're going to split this in half. And we're going to factor by grouping. And when we're taking a look at this first half, 6x squared plus 3x, what can we factor out? Yeah, that's right. We can factor out 3x. And so what's left? It's going to be 3x times what gives us 6x squared? It's going to be 2x, right? And so 3x times what gives us 3x? It's going to be just plus 1. All right. And so now when we take a look at the right side, what can we factor out of 4x plus 2? Let's factor out 2. And so, well, what does that leave us? 2 times what gives us 4x? It's going to be 2x. And 2 times what gives us 2? It's going to be plus 1. And then, of course, this is equal to 0. And all right, ladies and gentlemen, you'll notice that in blue it matches 2x plus 1 is factorable. So we're going to factor that out. Amazing. And what's left? 3x plus 2 equals to 0. And because, again, we're solving for the roots, what we're going to do, because we're solving for the roots, we're going to set each one equal to 0. 3x plus 2 equals to 0. All right, and so then, of course, we're going to subtract. We're looking at the blue side, right, the left side. We're going to subtract 1 from both sides. So we've got 2x equals -1, and then x equals -1/2. All right, so that's the first root. Tremendous. And what about the right side? What's the other root? Well, when we subtract 2 from both sides, we're going to have 3x equals -2. And then we're going to divide both sides by 3, and so it's going to be x equals -2/3. And that's the other half of the answer. Nice job. Question number 8 asks us to solve by completing the square. You will see this on the test. However, I'm going to intentionally not do question number 8. And instead, what I'm going to do is I'm going to urge you to check out my other video tutorial on completing the square. Let's move on to question number 9. Question number 9 asks us to solve using the quadratic formula. And if you're not familiar with the quadratic formula, you really should be. We know that when we're using the quadratic formula, the first thing that we're going to need to do is identify a, b, and c. In this case, a is 8, b is 2, and c is +1. And once we've identified what a, b, and c is, we're going to pop that right on into the quadratic formula. And so a is 8, so I'm going to pop in 8 right there and there. B is +2, and again, C is 1. And all right, so let's start working through this. And of course, we're solving for x. We've got to find the roots. All right, so negative times 2 is going to simplify to -2 plus or minus square root of what? 2 squared is going to give us, of course, 4 minus 4 times 8 times 1 is 32. Beautiful. And then 2 times 8, of course, is 16. The whole thing is over 16. Let's continue. I'm going to rewrite -2 plus or minus 4 minus 32 is what? -28. And again, the whole thing is over 16. All right, and so now what we need to do is anytime we ever have a number inside square root, what we need to do is ask ourselves, is this factorable by a perfect square? Does a number multiplied by a perfect square give us -28? And it sure does. 4 times 7 gives us 28, and 4 is a perfect square. So I'm going to rewrite this like -2 plus or minus the square root of 4 times the square root of -7 over 16. And what we're going to do is we're going to simplify this like -2 plus or minus square root of 4 is 2 plus or minus -7 over 16. And we know that we can't have a negative number and a square root. So what we're going to do is we're going to shift that negative sign out into an imaginary number. So it's going to be negative 2 plus or minus 2I plus or minus the square root of 7 all over 16. So a lot of you guys have expressed some confusion with this. All we did was we took the negative sign and we shifted it outside the square root sign so that it's represented as I, which stands, of course, for an imaginary number. So we're almost done. So this is the stage that we're at, and we need to ask ourselves, can we simplify this any further? Well, I know that 2 divided by 16 gives us what? 1/8, right? So likewise, we're going to apply that here, and we're going to simplify this to negative 1 plus or minus, and actually I'm going to pause, I'm going to do the whole thing over 8, because we're dividing both the numerators and the denominators by 2. And because this right here is all being multiplied, we can write 1, or we can simply leave the invisible 1 as a coefficient. So it's going to get, again, it's going to be negative 1 plus or minus I square root plus or minus square root of 7. And this, ladies and gentlemen, this is our answer. And because there is an imaginary number, in this case, there is going to be no solution. So that if we were graphing this, the minimum or maximum would not be touching the x-axis. Let's take a look at a few questions from version 2 from our sample test on foiling, factoring, and completing the square. And what we're going to do is we're actually going to jump down to question number 6. And I can see that it says solve for the roots by factoring. All right. And so what I know is that we're going to need to set this equal to 0 if we're solving for the roots. And what I know is that the first thing we should ask ourselves is there a GCF? Is there a greatest common factor? And when I'm looking at this, I can see that, yeah, what we can do is we can factor out 3. Great. And so what does that leave us with? Well, 3 times what gives us 3x squared is going to be simply x squared. 3 times what gives us negative 30? Well, it's going to be negative 10x. 3 times what is going to give us 72? Well, 72 divided by 3 is going to give us, of course, 24. Positive 24. And this is all equal to 0. All right. So now what we're going to do is we're going to direct our attention just to these 3 terms inside the parentheses. And I can see that the leading coefficient is 1. And so what we need to do is we need to figure out, all right, what 2 terms multiply to 24 and add to negative 10? Well, it could it be 1 and 24? Nope. Could it be 2 and 12? No. Could it be 4 and 6? Well, I know 4 and 6 multiplies to 24. And some combination gives us negative 10. So what I'm going to do is I'm going to rewrite that like so. And x times x is always going to give us x squared, right? And we just determined that 4 and 6 are going to be the numbers that we're going to be using. Positive 4 times positive 6 gives us positive 24, but that's not going to give us negative 10. Instead, what we're going to do is we're going to make both 4 and 6 negative. Tremendous. All right, and so what do we do now? We're going to be isolating just x minus 4, and we're going to be setting it equal to 0. Likewise, x minus 6 equals to 0, and we can forget about the 3. In fact, when you're working through these kinds of problems, anything outside of the parentheses or not connected to the variable, in this case x, we don't need to really think about. And so if we're looking at x minus 4, if we apply the inverse operation by adding 4 to both sides, that's going to give us positive 4. And likewise, x is going to be positive 6. So this is our first root, this is our second, and this, ladies and gentlemen, is the answer. Let's take a look at question number 7, and it says that we've got to solve by factoring. And this one might be a little bit tricky because the leading coefficient is not 1, in this case it's 6. So what we're going to do is we're going to multiply the first and the third term, 6 times 3, and that's going to give us, of course, 18. All right, and so now what we need to do is we need to think about what combination of numbers multiplies to 18 but adds to 11. All right, so I'm going to take 18, and I know that 18 divided by 1 is 18. 18 divided by 2 is 9. 18 divided by 3 is going to be 6. And all right, so do any of these combination of numbers, when added, give us 11? Well, it's not going to be 1 and 18, and it's not going to be 3 and 6. Yeah, 2 and 9, when added, give us 11. So what we're going to do is we're going to write this like 6x squared, and then it's going to be plus 9x plus 2x plus 3 equals to what? Equals to 0. All right, and so we've got 4 terms. We're going to be factoring by grouping. And so we're going to split this up into the first half and the second half. And when we're looking at this first half, 6x squared plus 9, what is the GCF? I can see that it's pretty clearly 3x. And so when we factor out 3x, that leaves us with what? 2x plus what? 3x times what gives us 9x? It's going to be simply 3. All right. And then on the right side, we've got 2x plus 3. What can we factor out? Nothing. Nada. So I'm going to write simply plus 1, and then 2x plus 3. And okay, what I can see now is that we've got a match. 2x plus 3 and 2x plus 3 are identical, meaning that we can factor these guys out. So it's going to be 2x plus 3 times 3x plus 1. Beautiful. This is always equal to 0. And now what we're going to do is we're going to set 2x plus 3 equal to 0 because we've got to solve for the roots. When we subtract 3 from both sides, we've got 2x equals negative 3. Then we divide both sides by 2. We've got x equals negative 3 over 2. And that's the first half of the answer. And what about the right side? So it's going to be 3x plus 1 equals 0. 3x equals negative 1 when we subtract both sides by 1. And then x equals negative 1/3. This is the other half. This is the other root. All right, so this is going to be the last problem in this video tutorial where we're going to be solving using the quadratic formula. Great, and when we're using the quadratic formula, I know that the first thing that we're going to need to do is identify what a, b, and c is, and I know that in this case a is 6, b is positive 2, and c is positive 1. And so let's start plugging these in. So if a is 6, I'm going to plug that in here and here, and b is 2, so we'll plug that in here and here, and then c, of course, is 1. Let's work through this, and we're going to be simplifying using the quadratic formula. All right, so it's negative 2 plus or minus the square root of 2 squared is 4, and minus 4 times 6 times 1 is going to give us 24, and this is all over 12. All right, so now what do? We know that it's going to be negative 2 plus or minus square root of 4 minus 24 is going to be negative 20 over 12. Great, and whenever we have a number inside a square root, we need to ask ourselves, is there a number that when multiplied by a perfect square gives us negative 20? And there sure is. We know that 4 is a perfect square, and so we're going to simplify this like negative 2 plus or minus the square root of 4 times the square root of negative 5 is all over 12, and negative 4 simplifies, the square root of 4 simplifies to 2, and if we've got a negative side inside a square root, we can simplify that to I square root of plus or minus 5 all over 12. Can we take this a step further? Can we simplify this when taking the denominator into consideration? Yeah, 2/12 simplifies to 1/6. 2/12 simplifies to 1/6. So this is going to look like -1 plus or minus 1i, or simply I, square root of 5 over 6. So we could write it this way, or we could simply write it like -1 plus or minus I, square root of 5 over 6. And that, ladies and gentlemen, is our answer.